Health data research is changing fast. New standards, new infrastructure, and new AI capabilities are reshaping what researchers can do, but also what institutions need to put in place to support them responsibly. Trusted Research Conversations is a podcast from Iridia for the people navigating this change. I'm Ross Stiven, your host, the Senior Product Manager here at Iridia, and in each episode, I'll be speaking to guests from across the research, clinical, and technology communities, discussing the practical realities of secure data research, federated analysis, AI governance, and the standards and regulations that underpin it all. Today, I'm joined by Wouter Franke, Data Collaboration and Integration Lead at the Hyve, and his colleague Liam Glück, a data engineer. So, Wouter, Liam, welcome to Trusted Research Conversations. Obviously, we're primarily here to discuss OMOP and the OHDSI tooling and the workflow and just generally what people have to do to OMOP their data. But as with all of our episodes, we let our guests introduce both themselves and their organisation before we dive into the topic of the day. So I don't know, Wouter, if you want to go first in introducing yourself.
Yes, Ross, thank you very much. My name is Wouter Franke from the Hyve. And at the Hyve, I lead the team around data collaboration and integration, which focuses work around OMOP and OHDSI toolkit, but also around semantic modeling, around some consultancy as well. And next to the leading of the team, I also enjoy doing some of the projects as a senior consulting. I'm mainly working then at a bit of the intersection of semantics, federated architectures, trust frameworks, and all of that I do with a background within computer science and organizational change. And that's also where I really enjoy working with customers, with collaboration between universities, hospitals, pharma, to enable them to basically get the best value from data, design the architectures they need for that and the governance. And I'm here together with Liam today.
Thanks, Wouter. My name is Liam Glück. I'm a data engineer at the Hyve, specifically in the team that Wouter was just explaining, what we call DCI. My background lies with undergraduate studies in biomedical sciences, and that was followed by computational biology. And as I realized, that was my main path forward in the same field. And since then, I knew that I wanted to get more work in the clinical domain, so here I am. Like Wouter said, a lot of our work and my experience as well revolves around OMOP projects, helping transform that data directly to OMOP and utilizing all those tools. But it's also extending into data modeling and different roles and different consortia for making data simply more research ready, however that comes along.
Excellent. Thank you very much. So I guess I don't know who wants to introduce the Hyve.
So we're from the Hyve, a Dutch company around open science bioinformatics. So we are working with pharma, academic, medical centers, public health data infrastructures, and we really aim to build and contribute to open source and open standard platforms and programs to enable to get, again, the best value from data, but also to do that in a setting where, in the end, our customers own basically the platforms they're working on, they own the infrastructure, and the community gets the improvements from these kind of developments as well. And it's around a different set of tools, so we operate around cBioPortal, and it's a visualization for cancer genomics, open targets, another tool we support. But in this case, the OHDSI toolkit and everything OMOP obviously is today's topic. We've been involved within the OMOP community since basically since the start. So we've been part of the Eden program or the European Eden project. We're doing a lot of different grants projects, but we also work for pharma companies, helping them with basically integrating own data towards OMOP data sets, again, to drive research.
Okay, thank you very much, both. So, I mean, I think that leads us on quite nicely, I suppose, to the first part of our discussion, which is really at a high level, what are OMOP and OHDSI? Like, what are these things, and what are the benefits of adopting OMOP, and how OHDSI can, help take you on that journey, to use a really terrible pun. So yeah, like let's just start with OMOP. Let's talk about the data model, what it is, where it comes from.
The OMOP, the Observational Medical Outcomes Partnership, it's a common data model, the OMOP CDM, which is a standardized schema for observational health data. So it's all around EHRs, claims, registries, where a standard set of tables has been defined and helps you actually to harmonize data, to have a structural standardization so that everyone's data lands in the same tables, same columns. It has a lot of the vocabulary standardized, so it uses the ICD-10, ICD-9, SNOMED, RX norm. All of it is necessary in the end to actually help people to work with data. And OMOP is in a sense a common language, a common data model to enable that translation between organizations as well.
I don't know if Liam, if there's anything you want to add to that or dig into there.
Yeah, I mean, so in essence, what carrying on with Wouter said, it's how you represent this data. There's massive ways of data that you're sort of extracting or getting provided from these clinical settings, right? And it's really built upon the foundations of many other organizations that utilize these standard vocabularies, right? SNOMED, LOINC, RX norm. So it's not just making its own wheel, right? It's adapting and utilizing lots of different segments from all over the world that have been generated over the last decade. So there's a lot of open source and community strength in there that's even extending farther. And we're going to go more into what's OHDSI, right?
Yeah, absolutely.
But so that's what's so powerful about this, but we'll get into it.
Yeah, no, absolutely. So I mean, I think that's quite a nice segue. So OMOP is the data model, right? OMOP is the standard to which data owners can harmonize their data. What is OHDSI, right? How does OHDSI relate to OMOP?
Now, maybe to add one more thing about OMOP.
Yeah, go ahead.
Because I think it's interesting as well. Obviously, it's OMOP is optimized for analysis and it's optimized for research. And I think that's an important characteristic of OMOP as well. Because obviously we all know FHIR as well. FHIR being used in hospitals, but that's optimized for the exchange of data.
Yes.
So it's so in a sense there are more standards, and I think it's important to understand that OMOP is really focusing on that research part. It enables the epidemiology. It's enabling a research environment based on the OMOP CDM. While there are also still a lot of other standards out there which are absolutely important as well. So that's always an important caveat with OMOP.
Yes, absolutely. So yeah, let's talk about OHDSI then. How does OHDSI relate to OMOP?
So OHDSI is in essence is the open science community that has created, developed, and are now maintaining the OMOP Common Data Model, right? But it's not as simple as just people agreeing what this framework and the schema and SQL tables look like. It's in essence a huge, enormous global research network, right? So it's filled with epidemiologists and scientists and data scientists and directors and informaticians and clinicians and doctors who all work together the huge majority of the time voluntarily. Out of their own time, because they're often coming from university roles, or they might be involved with the pharma, and this is just part of their work, right? But you often see how much they see the value in this community, and it's everybody working towards this open science mission, right? That all the model, the tools, the methodologies that we use is available for everybody to use, and they've put in a lot of effort to have all this documented to a really good standard, and so what they not only agree on the standards and the vocabularies and the ontologies that should be used, how they should be used, they also go into the tool development, right? And how applicable this is for the rest of people. So
yeah. I mean, I think it would maybe be interesting to talk a little bit about that tool development aspect, because that as a relative outsider, that seems to me to be one of the most important functions of OHDSI, is the development of the tools to allow users to both harmonize their data to OMOP, analyze the quality of it, and also interact with the data once it's once it's been standardized. So it would be, I guess, maybe interesting to dig into what some of the important tools that OHDSI has developed are and what their function is.
Yeah, I think in terms of tools, OHDSI has the Atlas for the cohorts, definition and characterization. There's Athena for vocabulary browser. Within OHDSI, you've got the Hades R packages.
Yes.
And I think you see already the theme that has been chosen here around the Greek mythology.
Yes.
This Achilles and the data quality dashboards. So a lot of these tools are out there. I think that's a very important component of OHDSI, but I think already what Liam said as well, the social architecture, social collaboration within OHDSI is also very important.
Yes.
It runs the community study-a-thons. It runs weekly calls to progress the OHDSI use and the OMOP CDM. They discuss methodological commitments in terms of how do we generate this evidence? How can we actually best utilize these kind of how can we best run these tools to come up with the best cohorts? So it also serves as a platform to really work towards reproducible studies around observational health data.
I mean, again, it's a truly like global community as well. I mean, there are, as far as I'm aware anyway, there are conferences on pretty much every continent. I mean, it's a genuinely global effort. I mean, that's interesting. So I guess to go from there, it would maybe be interesting to talk about what the typical kind of workflow is. So if I'm a data holder who wants to standardize their data into OMOP, I'm going to be interacting with these OHDSI tools. I'm going to be using them as part of my harmonization effort. What does that look like? I think a very interesting thing here is like, what are the challenges around OMOPing your data? Because again, as someone who's been in projects such as FEMS, which I guess we'll talk about later on, it's not a straightforward process, right? It's something that requires a lot of time and effort and collaboration to OMOP your data. So, let's talk a little bit about that. What is the process of moving from your data that you have in its existing format? How do I move from that to a fully OMOPed data set? What does that look like? Where are the wrinkles in that process? What are the things that people need to think about, probably even before they start? Like how does that evolve as the work progresses? Kind of happy to take that in whichever order you guys want to talk about it. Yeah.
It might be nice to start with a couple of the, in a sense, the challenges of working with OMOP. And it's not just isolated to OMOP, but it's to a lot of data harmonization projects. And I think Liam can then drill down a little bit in terms of our approach and quite often how that would look like with the different tooling. But in a sense, it's some of the challenges around working with OMOP. It's ETL, so building the actual code to transform to map data. It's one thing, but what quite often people don't think as much about is the semantic mappings. So if you have your own local codes, how do we actually map them to the standard concepts? Yeah. So it's a lot about clinical domain expertise as well, and clinical domain expertise in combination with expertise around the OMOP CDM. And that's one of the first challenges. And with it, obviously, with that semantic mapping, there's the risk of having a bit of, I'll put everything within the observation concept, or I put everything in the, I lose some of the information because I just put everything in the same dustbin of observational concept. Again, it requires local semantics, understanding of the local semantics, and understanding of the OMOP CDM. And in that sense, also, you can have two hospitals or two data owners both having mapped their data towards OMOP, but still having in a sense, a semantic drift between them. So it's not a 100% interoperable data source yet, because they might have applied the OMOP CDM slightly different. The compliance with the OMOP CDM might be different. So again, it's one of the things which and sometimes it's definitely a bit of a challenge. We see some challenges around domains. It's been built around claims and EHR data. Obviously, we see more and more data to be bolted on to the OMOP CDM. Oncology, genomics, imaging, all of that is possible. But I think we all need to be careful in terms of where do we put the borders and how do we integrate them to still make sense of keeping a relatively tight, controlled common data model. And obviously there's a maintenance as well. So quite often it's not a one-off. Vocabularies change, also the OMOP CDM changes. So there's always a bit of maintenance in there as well. And maybe the last challenge, and I think it's one of the biggest challenges as well, has nothing to do with OMOP CDM, but everything to do with data in general, its quality. There are a lot of tools within OHDSI and to work with what kind of data quality we have to generate insights around data quality.
Yes.
But still, the old adage of rubbish in, rubbish out is still valid also with OMOP.
Absolutely. Yeah, you can't harmonize away per data, right?
No.
Exactly. Yeah, I don't know if you want to maybe pick up on that, Liam. I don't know if there's anything you want to drill into there or...
Yeah, I would like to frame it like sometimes our customers are people who don't know OMOP as well, or who haven't had to deal with the limitations of choosing one or few vocabularies to represent their data. So and not to like Wouter said with the domain specific stuff, it's built for EHR. So in essence, it's built for your interactions with the healthcare system, right? The visits, the procedures, the tests, and the medications you get.
Yeah, absolutely.
Once you start delving into a little bit more experimental, genetic, biological factors such as that, where the variants, so when we talk about genetics, we're not talking about one of 10 different MRI procedures, we're talking about tens and thousands of mutations in genetics. It's really hard to represent this information well like that. So that's often sort of things people have to sort of understand when they try to adopt OMOP is, okay, I want to represent my data like this, and I need to accept that in order to use this vocabulary, I may have to, or this ontology, I have to look at my data a bit differently. And I might have to lose a little bit of information, but in the end, you're taking a step forward in making it open and harmonized and interoperable, right? So
I thought maybe you can talk a little bit about basically the standard process that we go through when we are asked to build ETL around OMOP.
So exactly, right. So that would also probably lead on to some nice examples of what could pop up. So we often start with, like Ross said, a data holder, right? And this can be anybody from a hospital to university to data vendors or whoever. And what we always start from, okay, what does your source data look like, right? How do you, as a clinic or so, store your data about your patients? So we need to see this to a certain extent, right? We also, as a company, we like to, let's say, not necessarily touch the data, right? We like to, so that's what also the tools being brought in from the OHDSI community, the benefits of them there. What the OHDSI community has are things such as like the rabbit tools, which are not necessarily Greek mythology related. They're another strange theme of these, where you can consider data profiling and data mapping, right? So everybody can use the rabbit tools because they're rather simple Java tools that you install just to look at your data tables, right? And it does this in a way so that in theory, if a hospital wants us to develop their OMOP data for them, we don't have to go searching and looking and indexing through every file and potentially stepping over GDPR issues and all of that, which I'm sure many, both of you will know, let alone our listeners. So we use these profiling tools to, in essence, look at your source tables, right? And that lets us know everything we need to know, at least the most important bits on what do your tables look like, what's inherently inside them, how do we need to transform your data? Are you already using nice globally standardized codes, such as from SNOMED or ICD, which tends to make your job easier of mapping to OMOP? Or are you making things more difficult, as in using free text fields to represent every single piece of clinical information you capture? Which is unfortunately more common than you think. And as we see in the field, but it also shows a good example. And so going back to these tools allowed us, right? We have a white, and I'm about to just say a bunch of tools that hopefully the listener will be motivated enough to go Google, because it's too many of them to introduce too much. But you can use the White Rabbit tool to profile your data, you know, and then we can see the reports, and then we have a great idea of, okay, you've got mainly EHR data. This can be represented in OMOP very well, or we can say, hey, you've got a lot of genetic variance data, and you know, you might have some limitations there. So that's the first step where we get to profile the data, and it's always going to require discussions with the holders because they always know the data best. Also, the clinicians know best how the data is captured, how it's recorded, why it's recorded in these certain ways, right? So we always need these discussions. That's always the start of our standard procedure, let's say. And then there are additional tools that are most that we like to call rabbit in a hat, which is in essence a diagram creative tool, right? That you map and you draw arrows from your source tables to the OMOP tables. And just to make that clear, so while we say OMOP is a unified schema, it is a unified schema, but it's a schema of in potential there's over 30 tables that you can use. In theory, fundamentally, you can have a very good OMOP, let's say, common data model just using 12 of those tables, right? The 30 is the full set that's probably unnecessary. So these tools allow you to really think about, in the context of OMOP, okay, how am I going to map my data? How am I going to represent it? What are the important bits? Where are all unique patients coming from? Are they coming from 1 or 2 or 3 different sources? You know, all these kind of logical steps. It allows you to take that sort of higher level visual diagram view. And so that's also a process we do with the people. It's also an open source tool that the OHDSI community has developed. And then lastly, you've got a tool that will help you map specific values that also follows the White Rabbit tooling naming. It's just Japanese with the name Usagi. And this is a highly used tool that has a nice sort of search algorithm in there. So, for example, when people come with their local source codes for how they represent data, you might be coming from Glasgow with a nice ibuprofen, 500 milligrams, right? Nice and simple in our eyes. And then in Spain, they have the Spanish version, but you know, they maybe the dose is coming from another field, right? Where you have yours in one field, and all these little minor details, and that's what the source tools help you to sort of map out. And this is immediately once you start to see some of the challenges, right? Where people go, oh yeah, but we have this cancer data, and for us, we really think of this in the clinical sense as a measurement, right? Because you're measuring how much. Whether metastasis has taken place or whether the person is in progression and stuff. And that's already where you have some issues where you have to accept, okay, but in OMOP, we represent that as a condition record, which is a valid, confirmed diagnosis and not a measurement, you know? So it's kind of these little, it's not really semantics, more about the mindset of how you represent your data, right? And this is often where people also need to a little bit of work to, and discussions to even understand and agree in the first place, right?
Yeah, absolutely. I think perhaps actually this is a good point for us to talk about the very specific example of FEMS, because I think you've touched on a lot of things there, Liam, which I think have come up like during the FEMS harmonization process, right? So, we have talked about FEMS in previous episodes, but I guess just as by way of a quick introduction for people that are listening, FEMS is a European consortium made up of pediatric hospitals and industry partners, both like ourselves in Iridia and you guys at the Hyve, with the objective of creating a federated network by which they can share data while retaining control of the source data and anonymity of the data subject. Now, our role in that is primarily providing the data federation software, which we've been developing under FEMS, and Hyve, the Hyve, is obviously working on harmonizing the data into OMOP and providing data quality reports on on said data. So hopefully that's enough background for anyone listening to this. So I mean, I can only speak from our perspective, but I think it's been a really kind of good collaboration. FEMS, it's been great working with you guys and everybody else in the project. And I think a really worthy objective, right? Helping, further the understanding and the treatment of rare diseases in children. I think that's something that we're all, very happy to be working on.
Absolutely.
But it's not a straightforward thing to build from the ground up. I think, yeah, I mean, from our perspective, I think as the Federation partner, the harmonisation piece and the data quality piece are just like absolute necessities, because if we can't do these things, then we can't have a federation, right?
Exactly.
So, yeah, I think it would be really good to talk about the specific process that you guys have gone through with the FEMS partners to agree an OMOP harmonisation for the purposes of running the federated network.
I think to start there, it's absolutely imperative, as you said before, if you have any federated environment, and let me take even one step back. It's about rare diseases in children. So with any rare disease, every site, every hospital has a small number of patients. And if you really want to do the research on it, you need to have a collaboration of multiple organizations to actually have the numbers to have statistically significant results for your studies. So with that, federation is a absolute, very important step of being able to analyze it. And as you said, to be able to do federated analysis, it all starts with the data that actually is harmonized and quality. But if you think back even about the different OMOP challenges, it even maybe starts a little bit earlier in terms of the decision. Okay, we want to use the OMOP CDM as the language in which we can all provide our data. But the first step is also then ensuring that we all think in the same time, the same manner. So we think about the same design principles that we apply to our data. So before we actually start even an ETL process in a project like that, it's all about the design guidelines. If you start mapping your data towards OMOP, what's your best practices for this specific network? And I think that's a very important step in these kind of collaborations to also prevent later on the drift between slightly different OMOP implementations. So I think this is also where it started at the first steps of FEMS, were to create those guidelines for all of the different sites to actually start working with. And then as the second part is, like you said, it's the building of the ETL, the pipelines themselves. And then later on is data quality. But also data quality becomes visible in the sense if you have the OMOP database, but already starts earlier. So also white rabbit scans can already help you to actually think about, okay, but what kind of values do I have in my database? Do they make sense, these values? I can have a dose which is 1,000 times the normal dose for a drug, because I might have misplaced or mislabeled anything in terms of grams or microgram. It's not an incoming issue within databases. So there's a lot of things that before actually the ETL is built already needs to be done or be in place, or after the ETL has built. But Liam can give you again more details around the process for FEMS.
Yeah, I always like to explain FEMS to colleagues of mine or people I meet in the community who work with OMOP but don't know FEMS is that. FEMS is one of the perfect projects that really push you to face a lot of aspects of OMOP, and having data in OMOP that isn't the easiest to confront. So for example, with FEMS, we started off from the beginning, you have the typical OMOP question of harmonizing 5 different hospitals' data into a same format, right? And like I said earlier, this was getting people to even agree. Of course, they've joined the consortium, so you hope, but then you still have to talk to all the clinicians and the IT managers and everybody, right? And what we realized at the start of FEMS was this, you really have to talk to people about changing their mindset a bit. And one of our older colleagues referred to the bit we have to do a cultural change for these hospitals, right? For them to understand what this project means. Because on top of that, you're mixing data, like you said, about rare diseases in pediatrics, which is after we are rightly so trying to preserve the privacy of our patients already who are at risk, when you combine pediatrics and rare diseases, you're coming to one of the most difficult areas in clinical research, right? So this was a huge part as well. And that is where your work from Iridia came in so strongly, right? The federated aspects, that was the whole base of it. But it was, moving on from what Wouter said, it was exactly that, acknowledging, okay, how each hospital literally represents their data very differently, right? And the exact information, and that we also came with these use cases from the start, right? So we don't have to go too deep, but assuming that your listeners might know is the 3 use cases. And the fact that it's not really just about making the data ready for analytics. It's making it's already taking this data that clearly some hardworking PhD researchers have already developed models around, and then to say, okay, how can we adapt the data in a way that your model still takes it and can still work with it, right? And especially with some of these more complex models, it definitely wasn't the easiest to simply just adopt OMOP, right? To the poor researchers and data engineers from these hospitals. So that was a new process for us, really figuring out how can we harmonize this in a way that really benefits each and every one of these institutes. And another challenge was that some of these institutes were coming from national infrastructures where they had, OMOP data already throughout the country, right? For example, from Finland, versus some hospitals who are starting their OMOP process, right? From scratch almost. So, and these are worlds apart in what they can achieve already in the first 6 months, a year, 2 years of the project. So this was really interesting as well. And we're still learning, right? Already in the past year already, and things have been gone for a bit, that we still had to change our mindset a bit on how we represent data, and that one hospital needs to represent this when you start dealing with important issues such as sepsis or cardiological benchmarks, or the fact that we're sitting there with the General Assembly talking to 5 clinicians, specifically cardiologists, agreeing. But does the surgery align with what you guys call this surgery, right? And you're really, in essence, getting away from the data and just simply saying, "Hey, do we all agree on this?"
That was a very eye-opening meeting for me. Like, I think it was a very interesting thing to understand the subtleties of like harmonizing your data at that very granular level, right? And that was a really interesting discussion. To listen in on. I mean, I think that's and I think it's with FEMS now, I believe for the first 3 use cases, the data is now harmonized. Is that right?
So that's also, I mean, so we didn't particularly do the harmonization ourselves. Our role was more there from a higher level advice, guidelines. So of course we spent the time to really look at all the source data and really provide them what our best summary of what you should map to, right? And this was a nice iterative process, right? Which was not done so easily. And in that case, from what we know, I mean, we know that we've had to prioritize some of the use cases over the others. But yeah, it's nice to see it took a while, right, for these hospitals to really get to the point where we say, okay, now we have our OMOP data and we think it's suitable, So, and once we have all the federated aspects working well, which you will know much better than I do, how well that's going for each hospital. From what I understand, it's going pretty well, right?
I mean, I think the cardiology use case. So, like, again, for people not familiar with it, this is benchmarking data for pediatric cardiology procedures. That now works. Like, so we have that in place across a network of European hospitals, so they can now share that data when they couldn't before. So I think that's a really, really, positive outcome, right, for the FEMS project.
Absolutely agree.
I mean, I think the thing we haven't really talked about under FEMS, and it is perhaps something that I underestimated the importance of at the start, I will admit to, is the data quality reporting, because one of our responsibilities has been writing the audits and controls policy for the FEMS network. So essentially like the rules that determine whether you can be a member of the network or not. And actually, one of the key things in that is going to be annual data quality reporting. So proving that you are providing a quality of data that allows you to be a full participant in the network. So it'd be good if we could just maybe cover a little bit about the data quality work that's happening in FEMS as well.
So yeah, I mean, so it's been a good process, and this also links back to what I said earlier, that different hospitals are coming from different backgrounds of, let's say, how prepared they were, right?
Yeah.
And their capabilities. So the data quality, for example, coming from Finland probably isn't going to be as much of an issue as example, or won't be as much of to worry about as, for example, where we have to perhaps Spain or such, who are starting that process off, right?
Yes.
Or at least we're much earlier in that process. I don't want to speak unfairly on any hospital. And yeah, exactly that. It's getting to them that you're not only going to have to look at data quality in the context of your machine learning model or your benchmarking, right, which is still really important, but you're also going to have to look at data quality in the context of OMOP and the OHDSI community, right? Because this project has different, it's got its different sides in that respect. And ideally, FEMS doesn't end with these 3 use cases, right? It carries on, and use cases can be developed and created and added in, right?
I think also not just new use cases, but also new members of the network.
Precisely.
They are, and I think having clear standards around things like harmonization and data quality, like there's really like foundational things, particularly for a federated network where the data will never be shared directly, right? You have to have that confidence that each of the partners is making their data available in a way that works for the network. Right.
Yeah.
So
exactly.
It's going to be for the future growth of FEMS. It's going to be really important foundational thing that all new partners and all new use cases meet these requirements.
Exactly.
Yeah.
It's really easy within the context of OMOP to do things differently, right?
Yes.
And this isn't so easy to identify in FEMS, but we also work in other projects where we work with even larger networks, right? And you'd be amazed how differently hospitals, for example, will define what a patient admission is, right? Some of them will define it on the exact time and day they arrive in. Some of them will take a day or two for it to process. And it's always, for some people, it's surprising, for some not, depending on experience, how simply different a patient's journey through a hospital experience can look like, depending on the system that they come from, and the level of detail there. So data quality in the context of OMOP gets affected so much by this, especially when it comes to what can we extract from the patient? Can we extract the dates? Are the dates that we have for this event actually reliable, right? And that comes to for example, one of our issues in the context of FEMS for these measurements was, what is a measurement date from one hospital to another, right? So when you go get a blood test, for one of the use cases is to do with sepsis, right? So the representation of blood tests and viral or bacterial infections that can be present is really important, right?
Yes.
And the simple question of, okay, what is the measurement date to you, starts a never-ending conversation, because to some people it's the date that the patient interacted with the doctor, where they get sort of prescribed, or the measurement is ordered, right? So the day that the doctor orders a blood test. In some hospital systems, this is the same day that you'll have the test done. For some, it's not, right?
Yep.
For some hospitals, they'll record the measurement date as the date that your biological sample was taken out. And like I said, this might be the same day. It might not be. It might be a week later. It might be a month later, depending on the test, right?
Yep.
So all of these things come into account. And another hospital will actually have the measurement date as a date that they obtain the results, and they know what the infection from the bloodstream is, right? So all of this is so different.
Yes.
And ideally, for the average data engineer or scientist, that might not seem like the crazy difference, but when it comes to this specific machine learning model that really is relying on these details, it's insane. It would be insane to think that you ignore these details, right?
Yeah, I mean, I think, even as a relative layperson, you can see
exactly
the problems that would cause in terms of building a predictive model. Right,
exactly.
Like if the day if our definitive date could be weeks or a month apart, that's obviously a challenge, right? That's great. So Wouter, Liam, I think that's been a really good overview of OMOP and OHDSI, and I think we've done a good job of. You guys have done a good job of grounding it in a real example with FEMS. So yeah, I just all it remains for me to do is thank you for joining us today. It's been a pleasure. So yeah, thank you very much.
Thank you. And if anyone is interested in OMOP or OHDSI, obviously join the national OHDSI node. Find more out. There's a whole community that's willing to help you and get you started on it as well.
Absolutely.
Yeah. No, thank you so much for having us. It was really, really nice to talk about it all with a fellow colleague from FEMS. So it's always nice to share the work we do.
Absolutely. Thank you. Thank you very much.